Afternoon. I'm glad that you're all out here today. Here's the obligatory Who Am I slide. I won't read it to you. Basically, the short form is I'm old, I'm fat, I have a big mouth, and I know how to use it. Got a bit of a shock when I realized earlier this year that I have been advocating the use of Linux and open source in industry for 20 years. That will make you feel old. But that's not what we're talking about today. We're talking about unikernels. We're talking about the future. Now, why am I talking about this? Number one, I am not a unikernel implementer. That's not my job. I'm Evangelist for ZenProject, the open source hypervisor that actually powers some of the largest clouds in the world. And you'll find a number, especially when I started this talk, I started doing versions of this talk about a year ago. And at that time, you'd find people talking about individual unikernels, but you didn't find too many people talking about the world of unikernels, trying to look at the forest and the trees. And so that's what we're going to attempt to do today. We're going to actually look at both the big picture and some of the small pictures. And this will affect the nature of the cloud, period. I'm going to make that statement because the nature of unikernels is so different from what we have running in the cloud today that we're going to have to rethink certain things about the way we deal with cloud. We'll get to that a little bit later. So first, let's talk a little bit about the forest. Why are we interested in unikernels anyway? What's the big deal? Well, I've been working with the cloud since before it was called the cloud. I was with a startup in California for a while, back in the early aughts. I don't know what else you call from 2000 to 2009. I've never really heard a good... The noughties. Okay, the noughties win. Back in the early times there, we talked about agile infrastructure. We didn't know what a cloud was. Then someone said, clouds. It's like, well, okay, clouds. But anyway, ever since that point till now, pretty much when you talk about cloud, you're talking about orchestration. How to make things do cloudy things, move around, come, go, do what they're told. And that makes perfect sense because that was the hard part. That was the thing we didn't have. We had workloads. They worked in the back room. Now we move them into the cloud, but we haven't done much with those workloads. The unikernel concept is going to attack those workloads, or at least some of them. So those workloads right now, if you look at them, look pretty much the same way as they did when they ran on iron. They're full application stacks. They have a full operating system. They've got utilities. They've got memory management, multi-user operating system. All this may be providing a web server. It's like, gee, that's a lot of stuff just to give you a web server or just a database or whatever it is that that machine is doing for you. So these VMs right now are beefy. They take up a lot of resources, a lot of memory. They're slow to start up, slow to shut down. Everything works, but it really isn't very efficient. And in the world of virtualization, up until about 3 years ago, if you were getting double digits of VMs live on one host at one time, you could be proud of yourself. It was hard getting 10 VMs on one machine because each one's so big, and there's only so much hardware to facilitate. But the next generation cloud, we have to start looking ahead towards the workloads. How do we make them efficient? They should be easier to deploy and manage. They should have a much smaller footprint. Get rid of the unnecessary cruft, fast startups. The concept of a transient microservice, which we'll talk about in a couple of minutes. People like to talk about microservices, things that are out there just giving responses as they're needed. But what about a transient microservice, a service that shows up just when needed and departs just when it's done? When we start talking about the Internet of Things and we start talking about hundreds and thousands and millions and maybe billions or trillions of things, every switch that's switched, every button that's pushed, something has to spring to life and do something. We don't want things hanging around like that. It would be nice if they would come and go just as needed. That's a transient microservice. We also need higher levels of security. If you don't believe that, just read the news. All these things that we thought were secure a few years ago, we're finding are not secure. from government websites to credit card companies to banks to finance, all of them. Hackery nonsense going on. Also, it would be wonderful if we could get up to thousands of VMs per single host. Big difference from the old days. Now, into this world comes things like Docker and containers. And they do some really nice things. There's some really interesting tech here. Makes that deployment picture a whole lot easier. It reduces the software footprint by leveraging and reusing a host. You need less memory, less disks. It makes the startup times a whole lot faster. All of that's really nice, and also much higher number of VMs per host. Well, are we in the promised land then? Well, there are still some issues. For one thing, you're sharing a host kernel. So running your Windows VM on your Linux host isn't going to work too well. So you've got to end up with a multi-operation environment. You also have issues of potential scalability. I mean, if all of these things are being shared, can you really get thousands of them on a single machine and get the optimal performance out of it? We're not sure. It wasn't really designed that way. And security. So much of what I hear about is how to catch up in security. Well, we need to jump ahead in security. Catch-up ball is way too late. We need to start moving forward in the security picture. So in comes the unikernel concept. And this addresses many of those same issues. It's very small. It's very efficient, very quick to boot, and by its nature, higher security. We'll talk about each of these in just a moment. This is green technology, and green as in energy, which can save you the green, the cash, the money, right out of the box. Because if you've ever had to sell into your organization or some other the notion of, oh, we have to do something that's green, and it'll only cost us, a year up front before we start getting returns, that's a lousy sell. That's hard. But this actually gives you payback immediately. And we have many unikernels out there, including Minios and Mirage and several others that we're going to talk about. Now, what is a unikernel exactly? How many people could give me a definition of a unikernel? Okay, that's fine. You're in the right room. So I'm going to steal a definition from the Mirage OS people. Mirage OS is one of the unikernels inside the ZenProject incubator. Their definition is, unikernels are specialized virtual machine images compiled from the modular stack of application code, system libraries, and configuration. You say, well, hey, that sounds like pretty much anything I'm running today, right? Well, not exactly. Let's take a look at some pictures. Now here is a picture of unikernel development. And on the left-hand side, we see the sorts of elements that we normally expect to see in software development. Configuration, application binary, language runtimes, all the way down to things like, the file system network stack. And when the compiler hits that, it takes those top three and compiles it into a mass, which sits on top of Unix and or Linux-like operating system, and it executes. Well, that's kind of the same picture that we do right now, right? When we do application development. Nothing really new there. But then you get to the testing phase and the picture changes. Now suddenly all of that stuff that's on the left-hand side is getting compiled into a single ball. And that sits on top of Unix and or Linux-like operating system. That's a little different. But then when you get to the deployment phase, the picture changes again. And suddenly that entire mass, from configuration down to the network stacks, becomes an image which sits directly on the hypervisor, which sits directly on the bare metal. What's missing? The entire operating system layer. It's gone. It's not there. It's not part of the picture in terms of the way it's structured. And that's kind of the big news. The unikernel concept is to have just enough to do the job. Get rid of the waste. Get rid of the stuff that's not needed. If you don't need multiple users, you don't put support for multiple users in it. If you don't need a general purpose operating system, don't have it in it. It doesn't belong there. You don't need utilities. You don't need all sorts of, you don't even need a full set of operating system functions. Think about it. If you're a web server, you don't need something that's going to talk to a database. You just need something that's talking over the network and reading other things in. You don't need access to a lot of stuff. So don't put any of those operating system functions in. That's waste. The result is lean and mean. Very tiny size. This is very similar to embedded programming. How many people have worked with embedded programming at any point in time? How many people who just raised their hand think this looks a little familiar to you? That's it. It's the same basic concept, but reapplied to the data center. Now, there are certain things we have to think about there. I mean, debugging changes, and this is one of the first bugaboos, you know, that developers sometimes say, oh, well, how am I going to debug this thing? There's no operating system, no utilities, et cetera, et cetera. But then when you think about it, if you're working in most production systems that I've dealt with over the years, no one's going to say, oh, here, take my production system and twiddle around with it for a while and figure out what went wrong. No, they say, take your logs, take your data, go back to your development system and test the crap out of it so it doesn't happen again. So the fact that your production system doesn't have all of those utilities, in most cases isn't a major obstacle because you're not allowed to use those utilities anyway on your production system. You have to reproduce. So what do you need? You need tooling so that your logs, et cetera, are rich enough so that you can figure out what went wrong if something went wrong. But that's basically the same game you have today. So really that approach hasn't changed. And the trade-off for this, though, is the whole ultralight image. And let's think about this for a minute. Here's some examples of some of these unikernel images. From the Mirage OS people, they have a fully functional DNS server which compiles into 449 kilobytes. Kilobytes. This is where some of us with gray in the temples need to turn to some of the younger people sitting next to us and explain what a kilobyte is. Most of us who've been around this industry haven't uttered the word kilobyte in 15 years. We're talking about gigabytes and terabytes and petabytes and, you know, kilobytes. Tiny, small. Fully functional web server, 674 kilobytes. OpenFlow switch, less than 400 kilobytes. Ling, another unikernel we'll talk about in a moment. Typical boot up time is less than 100 milliseconds. And the Erlang on Zen.org website, which is run by these people, which, you know, they're eating their own dog food. There's a little button there up in the upper right-hand corner, which allows you to see underneath the covers. And when I pressed that button for this slide, it said that that web server was taking up 8.7 megabytes. Can you now understand how we could possibly get 1,000 VMs on a single machine? If we're dealing with these tiny, tiny images that are doing what they're supposed to do, many things are possible. But is it powerful? Well, let's look at the Click OS people. That's from NEC Labs Europe. They have network devices which have already been shown to be able to handle more than 5 million packets per second, unikernel based. And this was an average size of about 6 megabytes with about a 30 millisecond boot time per device. This is major league. This is something different, something we've never had to deal with before. And what about security? Huge issue, of course. Well, a lot of these unikernels deal with type-safe languages. Not all of them. You don't need to. But if that's the area that you need to go into, there's a lot of coverage there. Now, a type-safe language can be certified. How many people have had to deal with software certification? Type, you know, fly-by-wire type things. I always note whenever I ask this question, the hands that go up very slowly because there is pain. There is great pain. In fact, about 2 years ago at our ZenProject Developer Summit, that we had a presentation that people gave about software certification and the pain that it causes. And one of the statements made was like, it's impossible to certify, say, a Linux stack because you would be spending millions of dollars and years of time, and by the time you finally got it certified, it would be so far obsolete that it would be useless to you. No, you need some stuff that's small, that can be tested and measured and analyzed. Unikernels fit the bill. Another interesting thing about security is that the footprints of a unikernel are individual to that particular unikernel system. Because you don't know that SSH is going to be out there. You don't know if there's an FTP. There's none of these things. You have to figure that out, and where were they placed in the compile, and so on and so forth. Tiny, small, and highly elective and selective. So that was the forest. Let's talk a little bit about the trees. What are some unikernels out there right now in the wild? What do they do? Well, here's a very partial list. Some of the better known ones, Mirage OS, HAL VM, Ling, so forth. Let's take a look at a few of these. Mirage OS is part of the ZenProject incubator. The language supported is OCaml. How many people know OCaml as a language? Congratulations, you have one. Of every time I've given this talk, I just saw more OCaml hands go up in one room than ever before. Wonderful. But still, fine minority. Not that many OCaml people wandering around. The hypervisor supported is Zen. They did a 2.0 release in 2014. They're supposed to be coming out with another release any time now. There's a lot of work going on there. It's suitable for general purpose devices, and it can be deployed on Amazon EC2. Being Zen-based and so forth, you can pop it out there. HAL VM from Galois supports Haskell. How many Haskell programmers? Once again, about as many as the OCaml programmers, and that's exactly as I expected. Also supports the ZenProject. Originally, it was to prototype operating system elements and components, and now it's used for general purpose things, including network devices. Ling, language supported. Erlang, how many Erlang programmers? About as many as OCaml and Haskell. And this is the thing, this is why when unikernels began work, people said, oh, I don't care about these esoteric languages, that's not my thing. So it's easy at this point to say, oh, it's for somebody else. But we're not done yet. But Ling also supports the ZenProject hypervisor, and it has an interesting little use case called the Zero Footprint Cloud. And it's a really interesting concept, because what happens if you have a cloud that is there when you need it and not when it's not? In the ultimate. I mean, think about it. Think about the Christmas retail classic situation. It's December 15th, and Big Box Store is about to announce a sale of the 80-inch color LED television for $29.95. You have several million people waiting there to push the button at midnight to get one of those deals. Now, realistically, how many web servers do you need occupied 1 minute before midnight? None. There's no traffic. There's nothing happening. And how many do you really want occupied once the sale is over, once everything's bought? Well, ideally, none for this anyway, just the usual amount. But when that button is pushed, when midnight hits, you may have millions of hits. You need all sorts of services available right then. ZERG, which is their Zero Footprint Cloud concept, says we can make that happen based on unikernels. Well, before I get there, let me just look at this. This is off of a scraping off of their website. Like I said, if you push the little button up on the right-hand side, it paints a little picture like this, which shows resources being used. And on the other slide, it was like 8.7 megabytes. And when I pressed it this time, where is it? I can't even see it. I'm getting old. I can't see it. Oh, there, it's 12.7 megabytes. That's kind of lightweight. But here's the ZERG demo. If you go there and hit their ZERG demo, it comes back with this little thing saying 300 seconds. That's about the amount of time that it takes to launch a Linux instance on EC2. 50 seconds, that's about as much time as it takes for one of these to come up and do something useful. 0.4 of a second is when they got the request, they launched an actual VM to respond to the request. It sent back this screen, and it was dead before you started reading. It lasted just as long as it took to get the job done. That's a zero-footprint cloud. You think, well, you know, what's the big deal? You know, so we have a bunch of stuff that's sitting around idle. About 10 years ago, I was working with a fellow in Southern Virginia who had just built a data center. He didn't even have the power on in half the building. He was bringing in the racks, wiring up the place. And he turned to me and said, you know, this data center's full. I said, full? You don't even have power in half the place. How is this full? He said, no, you misunderstand me. I know where every rack is going, where every server is going. And when I get every rack and every server and every wire in place, I will not be able to put one single more server in this building. So, well, why would you do that? Why would you build a data center that on day one is already full, no room for expansion? So, because I went to the power company and I said, I'm building a data center. How much power can you give me? And they said, this much, no more. So I had to build the data center around that much power. There's nothing else I can do. If I want more stuff, I need to go somewhere else and build another data center because there isn't enough power. In the world where things are getting bigger and bigger, where we're gathering more and more data, it's easy to think, oh, it's in the cloud. Well, in the cloud means that there's machines humming. And the more data we gather, the more machines it takes to record all this stuff, to respond to all this stuff. And when you run out of room, you start building more data centers. Power is not only expensive, but it's limited. And it takes power to start up these machines, and it takes power to cool them all down because they're generating heat as they're roaring away. If I had gone to that man back then and said, you know what? I bet you I can get you just 20% back. Just 20%. We would have had to scrape him off the ceiling. He would have jumped for joy so high. This is a real limitation. So the notion that we can actually take the resources we have and utilize them just when they're needed and then release them back to do something else somewhere else, that's important. And that we can do it in smaller packages, less resources being used. That's really impressive. Here's another one, OneClick OS from NEC Europe. Language support C, C++, and Python. How many C, C++, and or Python people in the room? There are a lot more hands up. A lot harder to poo-poo something like this. Once again, supports the ZenProject hypervisor. They released 0.2 in 2014, and it's kind of focused on network function virtualization. Here's one of their charts, which I borrowed from their website, and there you see that depending on packet size, they're getting 5.5 million packets per second being utilized. This is even an old chart. I'm told that they've got much better things to talk about these days, but this is the one I have on the slide deck. It's getting impressive. OSV, originally by a company called Cloudius Systems, which has now become Scylla or Skilla, I don't know how they pronounce it, DB. They've kind of moved on. By the way, if you're not an open source people, you think, they've moved on, okay, it's dead. Open source people, how many people consider themselves open source people? Cool. How many people know what Nautilus is? Piece of software called Nautilus. I've got it running here. If you're running a Linux box, chances are pretty good it's running there too. File manager. Nautilus was built by a company called Easel. How many people know the company Easel? Less than the number of OCaml programmers. Easel was a company that appeared during the .com/.bomb era. And as far as I can tell, the Easel product plan was to write cool code, throw big-ass parties, and go out in a ball of flame. Because as far as I can tell, that's exactly what they did, if that was their plan, because, you know. But one of the things that Easel produced was this interesting piece of software called Nautilus. And being open source, unlike a lot of companies that are closed source, they go belly up, their software goes into the bin of time and is never seen again. Nautilus survived. And suddenly, instead of being mostly Easel working on Nautilus, it's now an open source community that takes over the reins. And so Nautilus is still out there and it's alive. I expect the same sort of thing to happen here with OSV. Just because Claudius isn't trying to make $1 off of it at the moment doesn't mean it's dead at all. But look at their language support. C, C++, Java, Python, JavaScript, Node.js, Ruby. How many people have an interest in one of those languages? Yeah. This is where the forest and the trees thing comes in. You know, you might have been able to ignore some of those languages that weren't yours. But then you start seeing stuff like this, and it's like, well, wait a second, this is my turf too. Now, this is kind of different from your standard unikernel. It's kind of funny to talk about standards with unikernels because everything is so brand new and different. But it's a slightly different concept. They wanted basically something that could run a Java virtual machine. And they do almost all of it. It's like everything except forks. They'll do threads, but not forks. And that's pretty much it. So pretty much any jar file, you can kind of drop it on the thing and it works. And then they've got the ties to these other languages. It's interesting stuff. It is a fact in that because it'll handle any JVM almost, it does have more functions built into it. So you're not talking about kilobytes, you're talking about megabytes. Oh, have to deal with megabytes. But in this day and age, I mean, megabytes are pretty cheap too. So it's a little different tact, very interesting. It's optimized for network functions. Interesting piece of work. Then comes Rup Run. Now Rup Run, product of the Rup kernel ecosystem, and its field of focus is just about anything that's POSIX. How many people are running POSIX software at work? If you're not lifting up your hand, you probably don't know what the term means, because you probably do. Rup Run goes for just about all of that, and it opens the door to a huge number of potential applications. Now, if this really is a forest, and not just a group of trees, then a forest has an ecosystem, right? It has things that go on down below the tree line to make sure things continue to grow. So let's take a look at a few things in the ecosystem, and these are just a few things. There's a whole lot more, but these are some of the more interesting things. Jitsu, the just-in-time summoning of unikernels. It solves a problem, and that is if these things can literally come and go in fractions of a second, then we don't want to necessarily start it and have it hanging around. You can. That's your option, just like you do now. But what about if we just had it show up exactly when it's needed? So they tied in, the Mirage people, a DNS server to something that will not only will create the, will respond to the IP request, but then will actually create the VM that will respond to the IP request. So it's there just when it's needed. That's the Jitsu model. Interesting little beast. Minios. Minios is part of the ZenProject source tree. Actually, it just moved out of the source tree and it's now on its own in the incubator within ZenProject. Originally, it was designed for driver disaggregation, which is the notion of being able to actually pull things out of the hypervisor drivers and put them in their own individual VMs for security. but it's been used as sort of the jumping off point for people who want to build their own unikernels. OneClick OS did that, for instance. And the earliest version of Rup Run actually springboarded off of Minios. Rump kernels themselves. Now, this is a really interesting thing. It comes out of the NetBSD camp, and it's not a Linux thing. But NetBSD has always had this highly portable mindset and this notion that they should be able to pull in what they need to get the job done for their operating system. Well, some interestingly minded individuals said, you know what? This concept would work great if we pulled in just everything that we needed just to get the job done for a piece of hardware. Not even about an operating system. Let's go down the stack lower, and let's just pull in the operating system functions as well as everything else. That's what the rump kernel world is like. And rump kernels can work on ZenProject. They can work on bare metal if you have certain things in bare metal, and can actually work in user space as well. All a byproduct from its background. Here is an architecture slide from the rump kernel folks. And you look at the main box in the middle there and say, oh, you know, this is all pretty standard stuff that I'm used to seeing on a normal architecture of just about any application, until you actually look on the left and you see that it's a thread that goes throughout the entire stack. There is no differentiation. It's all part of one lump. There is no operating system. There's just one VM image. And here we go. The fat boy is wrong, and I'm glad to admit it. When I first started doing this talk, about a year ago, I said, well, you know, there's going to be some things you probably won't find as unikernels. You probably won't find a database. Well, guess what? The rump kernel people have a database. At least one. The only one I've heard them talk about so far, but MySQL. They actually, instead of having the LAMP stack, they now have the RAMP stack. Database, web server, and scripting language all together. So they have Nginx, MySQL, and PHP all running as unikernels. What's more, they didn't change any of the code to those application programs. They said that they spent all their time trying to get the compile right. Because remember, this is doing basically a cross-compile into an environment which is not native to the development world. You're building something that's going to run straight on a hypervisor. And they said Nginx was a little goofy. And that's only because they didn't document some of the things that they were doing in their compile. So it took a little while to make it work. But they didn't have to change the code. So if you actually have code that actually cross-compiles fairly well now, it could get interesting in a hurry. You may not have much work to do at all. So at this point, just about anything that's C or C++ can be made to just work in the rump kernel world. Not a bad thing. And here's some of the stuff. By the way, these slides are on ZenProject.org. All of our slides and presentations are out there, so you know, you don't need to scramble to write something down. But I just wanted to give credit where credit is due. Martin Lucina, Antti Canty, and a whole bunch of people working together on that stuff recently. Interesting stuff. Another part of the ecosystem is the ZenProject itself. As I said, I'm ZenProject Evangelist, and I'm not really talking about Zen here today. I'm talking about unikernels. But ZenProject, as you know, open source hypervisor for so many things for so long, we realized that, you know, 10 years ago, virtualization was a solution. Now it's plumbing. But the difference between plumbing in your house and plumbing in the cloud is that your house doesn't change design every 6 months. The cloud does. So we realize that just because we can handle today's workload well, doesn't mean we're going to handle tomorrow's workload well. So we are focusing on trying to facilitate these changes, because it is a big change. Remember, you know, in not so long ago, getting 10 or 12 VMs on a single machine, that was a lot. Well, we have a target right now, operationally, of getting 2,000 to 3,000 with no lack of performance. The last number I saw published by our guys was that they had 600 before they started to get a little top-off issues. I've heard that there's actually a better number since then, but I don't have it, so I'm not going to use it. But the idea here is that they've actually gone through and redesigned certain portions of the hypervisor, which were good design back when you had a dozen VMs, but didn't really make sense if you have thousands. And so there's this continuous work to make this work better and better. Another reason why you see Zen popping up so frequently inside the unikernel world is the notion of para-virtualization. Now, we're all used to hardware virtualization, and Zen can hardware virtualize as well as anyone else. And that is that you have a virtual machine which looks like a piece of hardware. So it says, oh, I have to send a network packet. I need to speak to the NE2000 net card that's sitting there. Well, is there an NE2000? No. But there's something that looks like an NE2000. So we got to pack up all the data and make it look like an NE2000 is going to eat it, and we throw it at it. And then the hypervisor has to go on the other end of the driver and unpack that and take it and make something useful happen. Well, that's kind of a waste, isn't it? You're spending all your time packing and unpacking data for a device that doesn't really exist. So the para-virtualization said, well, you know what? If the VM can be smart enough, if the guest can be smart enough to know that it's virtualized, we'll give it a really simple device, kind of a pipe, for lack of anything better. And we'll just throw the data down the pipe and say, here, do something with it. And we'll wait for a response, and the response comes back, bam. That's a heck of a lot more efficient. That's what para-virtualization comes down to. But the nice thing about the unikernel world, where everything's small and easy, it's real easy to code to para-virtualization because there's no elaborate driver involved. Very, very simple. So that's part of the reason why you frequently see Zen being one of the first hypervisor bases that gets used inside unikernel work. Now, there's more stuff coming. Every time I look around, there's more stuff. There's Arrakis, which is derived from the barrelfish operating. Anyone know what the barrelfish operating system is? I need to talk with you. You too. I've asked that question probably 8 times. I don't think I've ever had anyone yet who raised their hand. I just want to hear what it is. But Arrakis is based on that, which is cool. Clive, Go language. How many people interested in the Go language? Yeah. One that I just saw recently is Include OS, which apparently is C++ on KVM. Don't know much else about it, but it sounds interesting. There's a bunch more stuff coming out there. So are unikernels a panacea? No. No, no, no. There's going to be lots of things that aren't going to be suitable in unikernels. But if we can take the things that are suitable for unikernels and make them small and fast and light, then that gives us all the rest of our infrastructure to handle those big, heavy, honking things that need all that firepower. If we can make it small and secure, then those are things that we're not going to waste as much time worrying about. And we can focus in on those things which are much more elaborate and maybe have a rougher security spectrum. And I think that we're going to see as time goes on that all this stuff about, is it going to be containers, is it going to be about unikernels, 5, 6 years from now, we'll look upon this time as sort of the cavemen with their sticks beating on things. I think something new is going to come out of this. Something that's going to take some of this really interesting stuff out of the unikernel world, some of this interesting usability stuff that's coming out of the Docker container world, and we're going to see something even better coming along. But the unikernel stuff is going to be a huge part of it. So efficiency, security are being raised to new heights. Now, talking a little bit about microservices, and I mentioned transient microservices. The notion that, in the cloud, we start something, we say, are you started? Are you well? Are you happy? Are you ready? Now shut down. That's kind of the dialogue that goes on between the orchestrator and the service. A transient microservice, something like Jitsu says, hey, here's a request. Come alive. Hits the request, sees it, handles the request, dies. Gives back those resources. Total lifetime of that VM may be less than a second. How do you deal with that in a cloud? We don't have that concept in most clouds these days. This is something different, something new. You can't measure it. You can't check on it. It's dead before you even know it's out there. So this is a game changer. But we need to get there, particularly with things like Internet of Things, like I said before, where we're going to have lots of these little suckers all over the place. So you want them to be fast and light and get out of the way when they're done. And it's also much easier to be able to manipulate small things rather than big things. How many people know what Lincoln logs are? Thank you. I go to some places where you got a lot of youth, and it's like I ask that question, and it's like, huh? Google it when I'm done, okay? Lincoln logs, for those who don't know, it's a log cabin kit that you can put on a desk. And it looks just like a real log cabin, except the pieces are, this big. And you can move them around, you can build your little cabin, and everything's great. And if someone says, hey, build a new back room on that cabin, say, okay, I know, and in a minute or two, you've got that back room on that cabin. Now, if you have a real log cabin, and you say, hey, knock out that back wall, and let's get another room in here, well, you're going to be inside some serious work. When you take something that's big and make it small, you add something. It becomes more flexible, more usable. And in the cloud, that's what we want. So we need to take the big things and make them small so that we can get more done. This is one area where open source is leading the way. As I said, I've been dealing with open source for 20 years talking about people. And in the early days, it was like, oh, open source is only useful for imitating other things. Crap. Okay? This is leading the way. And it's because people like you are coming together and saying, I've got an idea. How do I do this? And someone says, oh, we could do that. Oh, we could do this. And so it's seeing the birth of something bigger and more innovative. And Zen wants to be part of this picture. We want to help focus on creating that next version of the cloud. Friends, don't let friends go closed source in the cloud. I'm sorry. And once again, our difference, we see our difference at ZenProject as being able to look ahead and try to enable that next generation. We're not settling for what we do well now. We want to go further and figure out what's coming next and do that well too. So we're trying to move things forward. We're going to have a session, not just an hour-long thing, but most of a day on unikernels and more at Scale, Southern California Linux Expo. If you're going to be out that way, please check on us. We're putting that together now. That should be really, really interesting. We did a half day at Texas Linux Fest just on unikernels, exceptionally well received. We're going to do something even better out there. So join us there. And we have our project newsletter. So if you just want to know what's coming up, sign up for the newsletter. I send it out, generally one a month. Takes about 4 minutes to read. That's it. No spamming of your inbox. And you can skip over things you don't want to see. We have all of about 30 seconds.
We can do one question. If you have a question, please come up to the microphone. Looks like we have one speaker. Great talk. So I'm curious, maybe you mentioned this, the stack where you showed Rup Run and SQL, other things.
Mm.
What was the footprint of that?
Well, that's kind of a generic stack. Excuse me? Oh, the question was in, let me see if I can find it. Inside the unikernel, Rup Run stack, which I'm trying to get up here, yeah. What's the footprint of this? Well, this is a generic stack. So basically, any of the things that are coming out of the rump kernel community look essentially like this. And they've got things that are anywhere from kilobytes to low megabytes, depending on what they're building.
Okay.
I mean, this is small stuff, and it works. I mean, obviously, the more elaborate the application, more room it's going to take. But most of the VM is the application. And all this other stuff that we're so used to having this mass sitting underneath is now minuscule, just what's needed to get there.
Okay, thanks.